Hi there, you're welcome back to my channel. In this video, I'll be taking you through the binary conversion to decimal. So in digital systems, you realize that there's a need to convert from the decimal domain towards the binary domain, okay? Because the computer understands zeros and ones, okay? So in this video, our focus is to look at the conversion in the binary domain to the decimal domain. Okay, I have some few problems here for us to walk through. Okay, so let's see. Before that, I have some few terms to introduce you to. We have something we call the most significant bit. Okay, most significant bit. Then we have the LSB, which is also called the least significant bits, the least significant bits. So whenever you see these two words here in terms of binary, then it means that we are talking about the most significant bit and the least significant bit, right? So how do we convert generally binary towards decimal? To do that, we tackle the LSB. Okay, LSB. So we start counting the LSB from 0, 1 up towards the, so we just be counting up towards the last term. Okay, up to the last term, right? So let me say something like n. Okay, so if you have a number like 11011 base 2, this particular number, this particular bit is what we call the least significant bit, okay? Because it is the last number here. Then this is what we call the most significant bit. That is the starting. So the least significant bit has a smaller value as compared to the larger or the most significant bit. So what do we do? As I said, we start counting from the least significant bit as 0, 1, 2, 3, then 4. So in that order, if more bits were to be added, then these numbers that we are assigning them to is just the power of 2. So you multiply each bit by what? The significance, okay? So let's say the least significant bit has a significance of 0, right? So 2 to the power 0 times the least significant bit. Then we add it to 2 to the power 1 times what? 1. So realize that the significance increases to the most significant bit. And in this illustration, the most significant bit is what? 4, right? I mean, has a significance of 4. So you just simply multiply it as 2 to the power 4 by what? 1. So this is the idea of the conversion from binary to decimal. So let's take our problems and walk through. So the first problem is 110112, right? So with this one, our least significant bit is simply what? The 1 here, right? Then our most is 1. So we start counting from what? The least. Starting counting from the least, that will have what? 0 on top. So you have here 0, 1, 2, 3, then 4. So these are the significance that we've assigned them to, right? So if you want to convert, simply you are going to have the first number, our most significant MSB, right? 1 times 2 to the power 4. So it looks like we are multiplying it with their significance, 2 to the power their significance. Then the next one is 1 times 2 to the power 3 plus 0 times 2 to the power 2, then plus 1 times 2 to the power 1, then plus 1 times 2 to the power 0, right? So here, this gives me 2 to the power 4 is 16, 2 to the power 3 is 8, plus 0 plus 4, then 2 to the power 1 is 2, right? Then 2 to the power 0 is what? 1, right? So this gives 16 plus 8, which is 24, plus 4, 28, plus 2, 30, plus 1, which is what? 31, right? Or let's do it again. So I have 16 plus 8, 24, right? So 24 here. So 0, 1, 2, yes, 0, 1, 2. Then I think this is 0, right? So it's 0. I introduced, so this 4 is not supposed to be there. So this 4 is not supposed to be there. So here is 0. So once you have that done, you simply have 16 plus 8, 24, plus 2, 26, plus 1. So there is 27 base 10. Okay. But you know, numbers in base 10, it's the same as we've been using. So if you see a number like 27 without any number, it means that 27 is what? Base 10. Okay. the accepted number we've been using is the decimal value. Okay, so now let's check the second one. The second one is 10110101 base 2, right? So as we did, we just label their significance. So starting from the last, LSB 0 1 2 3 4 5 6 7, right? So I'll start from 1. So I'll start from 1 by 2 to the power 7 plus 0 times 2 to the power 6 plus 1 times 2 to the power 5 plus 1 times 2 to the power 4 plus 0 times 2 to the power 3 plus 1 times 2 to the power 2 plus 0 times 2 to the power 1, then finally plus, so finally plus 1 to the power 1 times 2 to the power 0. Okay, yeah, so there is expansion here. So at this point, what's 2 to the power 7? 2 to the power 7. So 2 to the power 7 is going to give us 2 to the power 5 is 32. So there is 32 here, and this will surely be 64. So obviously this will be 128, right? Then plus 2 to the power 4 16 plus this 0. So this should give us 0. But this is also times 0, so this will also give us 0, right? So 64 here will be 0. Then obviously 2 to the power 3 times 0 2 will be 0. Then plus 2 to the power 2 times 1, which is 4. Then 0 here will be 0. 0 times 2 to the power 1 is 0. Then 1 times 2 to the power 0 is 1, so 1. So obviously we are getting 4 plus 16 is 20. We are getting 42, right? 42. Then there's 1. So 42 plus this, we are getting 100, and so that will give us, let me scroll upwards here. So as I was adding up, 16 plus 4 is 20, so 52. So I'm getting 128 plus 52 plus 1, right? So what is this? This is giving me 78, right? So this is going to give me 181 base 10. So that is that. Now let's check the third one. The third one, I have 11001.11 base 2. So here you realize that there's a decimal part. Sorry, the decimal points we know is when you are dealing with 4 decimal values, right? So in binaries, we also introduce a decimal point here, which is called a floating point. Okay, a floating point. So a floating point simply means decimal what values. Okay, decimal values. So any bit which is after the floating point here, that one, it goes the otherwise. We start counting the significance right from what the term after the decimal point. So as for the left side, we count it this way, right? So 0 1 in that order. But for the right side of what the floating point, we count it this instead, right? So we start from 1. It doesn't start from 0, please take note. You start from 1 2 3 in that order. Okay, so this ascending, they are all ascending but in different dimensions, okay, so let's see how we can apply that. So quickly, let's allocate the significance on top of each bit. Okay, on top of each bit. So on top of each bit, I'm having this to be, let me use black. So I'm having this to be 0 1 2 3, then 4. Then here starts 1 2 3. Okay, so once you get this done, let's see. I'll have the first one by 2 to the power 4 plus 2 to the power 3 times 1 plus 0 times 2 to the power 2 plus 0 times 2 to the power 1 plus 1 times 2 to the power 0, right? Now, we are done with what? Our right side. Then our left side, we are done with our left side. So for this side going, what you do is you take 2 to the power negative of the significance. We don't take it as the positive, it's negative. So you are going to have something like 1 times 2 to the power negative 1 for this particular one here. Okay, then the second one becomes plus 1 times 2 to the power negative 2, then finally plus what? So it's 1 1 here, so that's all. So this is not part. Okay, so this what you have to compute here. So at this point, you are going to get this here. 2 to the power 4 is 16 2 to the power 3 is what? 8, right? 0, 0 are gone. And I'm going to get 2 to the power 0 as 1. Plus now, this is what? 2 to the power negative 1 is the same as 1 over 2. So I get 1 over 2 plus 1 over 4. So this, you're going to get 1 over 2 to the power 2, which is 1 over 4. Okay. So getting this expression, 24, 25, right? Plus, if you have half plus 1 out of 4, what are you getting? You're getting 3 out of 4, right? So you're getting 3 out of 4, which is 3 quarters. So what is this giving me? This is the same as what? 0.75, right? So 25.75 base 10 will amount to this in base 2. Let's finally take our last one. So for our last one, we are having 10101, 10101 dots, right? 110. So dot 110 base 2. Okay. So likewise, as we did here, you just start counting our significance. So here, as I said, is 1, 2, then 3. Okay. Then this 1, 0, 1, 2, 3, then 4. Okay. So from here, you write our equation, not equation, but our expression. So I'll have 1 times 2 to the power 4. For the sake of time, all the zeros, you can ignore them. Then you move to the next one. Plus 1 times what? 2 to the power 2, right? Then the next one is what? Plus 1 times or 2 to the power 0, right? Plus, then you move here. So at this point, so I'll have 1 times 2 to the power negative 1 plus another 1 times what? 2 to the power negative 2, right? Then it's also 0. So zeros, I don't want you to focus on them because they are zeros. Everything will amount to 0. So here I'm getting 16 plus 4 plus 1, then plus 1 out of 2, then plus 1 out of what? 4. Okay. So at this point, 4 plus 16 is 20. Plus 1, 21 plus 3 out of 4, right? So 21 plus 0.75 giving me 21.75 base 10. Don't forget. So whenever you are doing base 10 or number basis conversion, don't forget to introduce the right basis below the number like this. Thank you for being with me in this video. Don't forget to subscribe, like, and share.